Hello friends, so welcome to Rhchemistry. In today's JEE MAIN 2020 bits from Nta Abhyas. So I have considered haloalkanes and haloarenes, 10 questions from this. So first, if you want, you can take the screenshot of these 10 questions and you can solve, and then I am going to solve in detail. So these are the first and second question, third, fifth, and this is fourth question. Third and fifth you can take. Then it is fifth question. You can take the screenshot. So then sixth and seventh question. Then eighth, ninth and 10th question. So these are the 10 questions which I am going to discuss in today's video. Yes, let us start with. Here a very important thing is you have to stick to the basic. So very important point is that 1,2-methyl shift, 1,2-hydride shift, that you have to be very careful in most of the reactions. First question, the incorrect statement regarding the SN2 reaction. First thing you remember, SN2 reaction means one-step reaction, simultaneous attack of nucleophile and leaving group which will leaves from the molecule and which will results in inversion of the configuration. Hence, which is incorrect they are asking. The reaction is favored by strong nucleophile. Definitely correct. An enantiomer of the reactant is formed. You have to think about this. A single stereoisomer is formed during the reaction. Definitely it is correct because only inversion is possible. The group which stabilizes the transition state increases the rate of reaction. This is also correct. But enantiomer of the reactant is formed, that is wrong, remember. Because here it is depending on some more conditions. So directly we cannot say enantiomer is going to form. In this case it is not going to form. Hence the answer for this question is, remember, B. Then second one. In this case CS3C, CS3, CS3, CHBr, CS3, E1 mechanism they are telling. Remember, E1 and SN1, the difference is two-step mechanism both, and only thing is first order reaction, everything is correct, but it is elimination, that is nucleophilic substitution. So that is the only difference. A is the major product they are telling. What is A? For this you have to write the reaction. So immediately you have to write the reaction, remember. So in this particular case, so CH3, C, CH3, CH3, so CH, CH3. So E1 mechanism means bromine should be removed, then the hydrogen should be removed, right? So bromine is removed. Just imagine, I will write the positive charge here. Carbocation is formed. Now this carbocation is not stable. Whenever the methyl group is there here, or when there is an opportunity to make this as a tertiary carbocation, you have to think about that. So when you make it as the tertiary carbocation, 1,2-methyl shift take place. Remember, 1,2-methyl shift take place. So hence I can write this as CH3, C, CH3. So it is having positive charge now. So CH, so CH3 and CH3, right? So this is the 1,2-methyl shift, what we call it as. Then positive charge, the carbocation which is formed here. So remember, this hydrogen which will leave from the this particular site, and double bond is formed here. So that the product of this is double bond here. So like this is the product. So hence the correct answer for this question is B. So remember, with the very short time you have to select this type of answers. So for that very basic thing, this type of thing you have to know. That is the second question. Now you will see third question. In case of the third question, you can see the, observe here. So benzene ring, iodine and CS3 is given. Then NBS. What is NBS? NBS is N-bromosuccinamide and it is used in, remember, allylic substitution. Remember, allylic substitution. Very important. And for this I have written I have explained it in the synopsis part also, that the notes are given in the description box, that also you can download, right? So NBS means N-bromosuccinamide. So allylic substitution take place. So now allylic substitution product, we will see that later. Allylic substitution take place means, I will write the product here, you can say. So this is nothing but iodine is here and CH is here, right? CH2 I will write. Now CH3, but the substitution take place at this carbon. Now allylic carbon means, remember, this one. So CH double bond CH, or you can say starting from here, CH single bond CH, CH2, and here double bond is there. So it's double bond. So allylic carbon is, remember, CH3, CH double bond CH2. This is allylic carbon. Now starting from here, CH3 double bond here, CH here. So that this is allylic carbon. So this hydrogen is replaced by Br, allylic substitution, bromine substitution take place. Now the second case, this is A now. This is A, directly I have written. Then KSH, remember, K plus SH minus. So it is like potassium hydroxide. It is potassium hydrosulfide. Potassium hydrosulfide. This is also strong nucleophile, remember. Now very good leaving group is iodine, no doubt. But iodine directly attached to benzene ring. So this cleavage is difficult. So that, remember, this cleavage will take place. So you are going to get the product as iodine is here and CH2 SH is here. So the answer for this question is C. Now, fourth one. The major product in the following reaction is. The major product in the following reaction. See, what type of reaction is given? Like this, CH5OCH3, CH2, CH2, CH, CH3, CH2, Cl, AlCl3 anhydrous. Then H2O is given. Now, what happens when AlCl3 anhydrous is used? So this will take up this chlorine. Remember, this will take up this chlorine. So that carbocation is formed here. So that carbocation, so that I will show it here. You can see clearly, will understand here. So this OCH3 is not touched at all. So this carbon is there, this carbon is there, this carbon is as it is, this carbon as it is, this carbon. Here I will write CH2 plus. Because AlCl3 will take this Cl to form AlCl4 minus. It is just like a Friedel-Crafts alkylation. Only the difference is here, this is just like CH3Cl, in presence of AlCl3, reagent is not given, reactant is not given. So, this is the carbocation formed, and this carbocation will replace this hydrogen from this hydrogen, adjacent hydrogen. So, remember, it is going to form a cyclic ring formation. But this is a major product they are asking. This is minor because carbocation is primary here. Now, what happens? There is a hydrogen atom here, right? Hydrogen. Now this hydrogen shift to this carbon, positive charge shift here, so that you are going to get the reactant, the product like this, remember, like this, 1, 2, 1, 2, this 3 I will take it here if you have no problem. 3 I will take it here. Then this is nothing but this is CH3. This is CH3 I have written here, CH3. And remember, this when it shift here, I will write positive charge at this carbon, right? And this becomes CH3. This becomes CH3. I will show it here. Correct? So clearly you take one paper and pen and you write down. That is the way you can understand this type of problem. Remember. So it looks to be complex, but it is very simple. See, hydrogen will shift here. 1 to hydride shift take place. CH3, that CH3 I have written here. And on the same carbon, another CH3 I have written here. So 1, 2 and 1, 2 carbon and positive charge I have written here. Now what happens is there is a one hydrogen here, right? There is a one hydrogen. Now this carbocation attacks on this carbon, this hydrogen will leave the surface. So that you are going to get it here in this particular case. This ring already it is there. This type of thinking is very important. Remember, this ring already it is there. And this one carbon, this one carbon, this one carbon, we cannot a shift, and this carbon will form a bond here. Now two CH3 groups are like this. So which is the correct answer? Yes, very good. B is the correct answer in this particular case. Like this, we have to solve this type of question. Now, increasing order of reactivity. So increasing order of reactivity, following compounds for SN1 reaction. SN1 reaction means two-step reaction, correct? So the reactant you can see here, CH3, CH, CH3, CH2, Cl is given primary. Here it is primary. Here it is also primary. Here it is also primary. No doubt in it. But carbocation stability is very important. Out of the four, which carbocation is more stable if you see? Which carbocation is more stable if you see? We have only three options. B you have to leave it. B you have to leave it. A, D and C we have. A, D and C. A, D and C. Now you can see, compared to this, remember, this is more stable because benzyl carbocation is going to form. Carbocation is forming here. Benzyl carbocation more stable. No doubt in it. Now, Okay. So this carbocation is more stable because OCH3 group is there. Because of this plus R effect, remember, it will donate the electron to benzene ring. So in turn, this positive charge become more stable. Because of that, definitely C is more, two options left. Then D is more. Then out of these two, if you see, in this case, again, two CH3 groups are there. So that it will donate the electron, plus I effect, you can call it as here plus I effect. So A is more than B. So the answer for this question is C. Remember, C more than, that is this more than this, more than A, more than B is the answer. This is primary, so it is least. So answer for this question is C. Third one. Then, in this case, the major product formed in the following reaction is R. So, major product following C. Here, some important points what you have to remember is, this type of reagent when they provide, this type, or you can say ETONA, all these when they are given, not necessarily to confused with, all these are, remember, this or this, all these are dehydrohalogenation reaction. Very important. Alcoholic KOH will tell. Alcoholic KOH means what is the meaning? So that potassium or sodium salt is going to form with the alcohol. Hence remember tertiary butyl alcohol with KOH. Sodium with ethyl alcohol, like that. So this is dehydrohalogenating reagent only. Now our thinking is very simple. So this Br you have to remove, and hydrogen you have to remove from here or here. You have to make a double bond. So in this particular case, remember, so dehydrohalogenation take place, first step, here there is a double bond. Now this Br is removed. Whether this hydrogen is removed or this hydrogen is removed, that is depending on its stability. Always remember, dienes, whatever it is formed, dienes, substituted dienes, that is more stable. Always remember, here or here you can use the same Sitjep's rule, no difference at all. But conjugated dienes, what we call it as, that is more stable. Double bond here, single bond, double bond here. Not double bond present in this is not more stable. Hence, because of that reason, this double bond and this double bond is more stable. I will write it here. Right? So this double bond and conjugated system, this double bond is more stable. Now the thing is, ozonolysis, very simple. Ozonolysis, and this is the dimethyl sulfide as a solvent. Fine. Ozonolysis, writing the product is very simple. I have told that in the hydrocarbon chapter also, you can see. Now, this you have to break, this you have to break. Here one oxygen, here one oxygen, here one oxygen, here one oxygen. So that here you can see C double bond O it is. Right? C double bond O, already H is there. So you are going to get CHO bond CHO plus this one, this CHO bond CHO. Now you can see here CHO, right? CHO. It is CH2 CH2, CH2 CH2. Right? And this is once again CHO. Hence the answer for this particular question is, remember, A. It's a very simple question. So A is the answer in this case. Now, seventh one. Here also the major product of the following reaction is. Remember, for JEE point of view, this elimination reaction is very, very important, my dear students. Remember, the major product of the following reaction is, they are asking. Once again, alcoholic KOH, excess they have given, 2Br is there. Correct? So hence, I will write this pH, and this is one carbon. Here it is Br. Then here it is like this. Then here it is Br. Now, by removing this Br and this Br, where you will form a double bond, that is very important. Remember, that is very important. Now, here you can see, here also it is conjugated system, conjugated, it is not conjugated, so C never be the answer. That you can say it very easily. Here there is a conjugated system, here there is a conjugated system, which is more stable. So remember, here pH group is there. Correct? pH group is there means this double bond will get the resonance stabilized because of this pH. This double bond get more stability because of the resonance with the pH. This one and this one, only two options we can keep. That is the shortcut to remember this. Remember, so like this it will form. So out of these two, this is not conjugated, so this should be the answer. D as answer, you can tell it very easily. Fine. Now what happens is, remember, here there is a one hydrogen, here there is a one hydrogen, here there is a one hydrogen. That is your choice from where you will remove the hydrogen. Right? Now this hydrogen I will remove, this Br I will remove, and double bond is formed here, this one. Right? Now this hydrogen is removed and this Br is removed, double bond is formed here, this one. You can ask, sir, I will remove this hydrogen. Yes, you can remove this hydrogen. But they are asking major product. You can see major product will have more stability. So this is minor product. Definitely this is the minor product. This is the minor product. But major product they are asking. Here there is a double bond. And here there is a double bond. Conjugated system. And then you can see 2 carbon here, 2 carbon here. So the answer for this question is D. So this is about the 7th question. Then 8th question, the major product formed in the following reaction. Here also you can see alcoholic KOH. Most of the reaction you can see that alcoholic KOH part. Now, major product of the following reaction, first HBr, then alcoholic KOH. Fine. So this is the reactant they have given. Cl is here, double bond O. Right? So HBr when you add, what happens? This will add H to 1 carbon, Br to 1 carbon. This is just addition reaction, remember. H to 1 carbon, Br to 1 carbon. Right? So now, to which carbon you have to add Br and we have to add H. See, here also you can add Br, here also you can add Br. But my choice is this one, because if you add Br here, Cl, Br at the same side, definitely there will be repulsion, stability will not be there. Because of that hydrogen I will add it here, Br I will add it here. So that my choice of product is like this, double bond O, and here there is a Cl, and double bond, here there is a Br, and here there is a H. Right, here there is a Br and here there is a H. Now, in this particular case, remember, so they have given alcoholic KOH. Right, alcoholic KOH means what? So removal of hydrogen and halogen, dehydrohalogenation. So in such case, if they have not given excess also, you have to remove both Cl. Remember that very important point. If they have not given excess also, you have to remove both Cl, because here major product we are going to write. Right? So hence, this Br we remove, this Cl also we remove, this hydrogen also we will remove, and this hydrogen also we will remove. This one hydrogen, this one hydrogen. Any hydrogen you can remove it here, because both the hydrogen will be conjugation with this double bond, and also this double bond and this double bond will be in conjugation. Right? Because of that reason, what we will do, in this case, it's better this Br and this hydrogen I will remove. Right? Or this Cl and this hydrogen I will remove, or this Cl or this hydrogen I will remove. See, alcoholic KOH. Alcoholic KOH. So best option is, remember, will go like this. So this hydrogen and this Cl will remove, so that you are going to get double bond O, and here there is a one double bond. Right? So conjugation to this, instead of removing this, remember, conjugate dienes are more stable, correct? So hence this hydrogen and this Br will remove, so double bond. You can do it like this also, this double bond here, this here double bond. I have considered this choice. Now this is not stable, because it is keto form. It is keto form. Now enol form we will write. Enol form. Enol form is what? This is CH2 group, right? CH2 group. Hence this hydrogen I will write it here double bond, and this will make O minus, and H will become OH. So which here, if you are not seen, I will show it like this. So, right, keto form. Hence we will write enol form of this. Enol form of this, when I write, remember, like this, here double bond, here double bond, and H from here it will make a double bond here, and O minus become OH. So O minus become OH. So I will write OH here, double bond here. So with the structure which is resembled to phenol, so the answer for this question is C. Remember, answer for this question is C. Remember, very simple. So Cl is there, HBr when you add, so it is double bond addition reaction, Br here, H here. Why not Br here? Remember, Cl and Br both are larger group, hence repulsion will be there. Then alcoholic KOH, either this hydrogen you can remove, or this hydrogen you can remove, or this hydrogen you can remove, but you have to take care that. So always remember, conjugated dienes are more stable. This point it is very important. Conjugated dienes are more stable. Remember that point. So now conjugated diene is going to form. Right? Now in this case keto form is there, and enol form is more stable. Because of the resonance it is more stable. So we will make it phenol form. So the answer is C. Now in this case, 9th question. Which of the following will produce precipitate with AgNO3? Precipitate with AgNO3, when you will get AgNO3 when it reacts with Br minus from all these to form AgBr precipitate. This is the basic thing. Correct? So to form this AgNO3 precipitate, Br minus should be free. Now we will remove Br minus from all these and we will see the stability. Always remember one very important point. These will donate Br minus only if the carbocation is more stable in these. For example, I will tell you this one. This when it remove Br minus, remember, so it become carbocation is here and plus Br minus, and it is least stable among all these. Definitely it is not going to form this Br minus freely. Hence, this will never give you precipitate. Like that concept you have to use. Now, when you remove this Br, remember on benzene ring itself, the phenyl carbocation, we will call it as phenyl cation. It is not at all stable. Hence, remember this is also not the answer. Now, this one you can see. This one when it form, remember double bond here and double on that double bond carbon plus charge is there, carbocation. On a double bonded carbon plus charge is there, definitely there is no resonance in this particular case. So it is not that much stable. Now we'll come to this. Now if you see when I form a double bond in this case, remember, so double bond here, double bond here, double bond here. This positive charge is resonance. So here you can see this positive, this is not stable. It is vinyl carbocation. But this is the secondary carbocation which is more stable because of these conjugated system and this conjugated system. Hence remember answer for this question should be A. So that Br minus will give it a very easily and forming AgBr precipitate. Now the 10th question, last question. The major product of the following reaction is. Major product of the following reaction. Once again here you can see alcoholic KOH is there, NaNH2 and liquid NH3 is there. One thing I will let me clear, alcoholic KOH and NaNH2 and liquid NH3 both are very good, remember, very good dehydrohalogenating agents. In hydrocarbon chapter I have explained that. You can see alcoholic KOH and NaNH2 and NH3 both are very good dehydrohalogenating agent. Now we will see, just imagine this Br and this Br is there, correct? So first alcoholic KOH when we use this Br from here, H from here we will remove. Or you can say this Br from here, H from here we can remove. So we will select this only because according to Sijep's rule, this double bond is the more stable, more substituted one, right? So this is the one double bond you are going to form like this. CH3, CH2, single bond, CH, Br, double bond CH, yes, in this case Br from here you have removed, Br from here and H from here you have removed, sorry, this H is not coming, so C double bond, CH2 it is, C double bond CH2. So what I have removed? In the first step, Br from here and H from here you have removed. So you can remove Br from here, H from here, no problem at all. So now this will undergo once again dehydrohalogenating reagent. So this is going to form the compound like this, because next time what it will do, Br from here, sorry, I think you have not seen this question. I will show you once again. So from this when it reacts with alcoholic KOH, Br from here, H from here it is removed. So that remember HBr is removed. So double bond is formed here, double bond C, double bond CH2. It is not H, C double bond CH2, Br is there. Now in the next step, Br from here and H from here it is removed. So that triple bond is going to form. So the answer for this question is D. Right? So this is about, these are the 10 questions which I have discussed under the JEE main part of haloalkanes and haloarenes. If you understood this concept, share it to your friends, those who have needed this. And if you like the content, if you are not subscribed, please subscribe to my channel. Thank you. Have a nice day.